In this section, we're going to look at dividing radical expressions. The quotient rule for radicals says for any real numbers where the nth root of a and the nth root of b exist, and b does not equal 0, that's very important, then if we have the nth root of a over b, we can break it up into two parts, the numerator and the denominator. We can have the nth root of a divided by the nth root of b instead of the nth root of a divided by b. Basically, if the indexes match, you can take a fraction and break it up into two separate radicals. Let's do some practice exercises. Starting with the first one, we have the square root of 49, a to the third, b to the eighth, all divided by, in the denominator, the square root of 7, ab to the seventh. Let's see if we can rewrite this. Well, the indexes are 2 on both the numerator and denominator, and we can rewrite this as 49 divided by 7, which is just 7 in the numerator. A to the third divided by a is a to the second, and b to the eighth divided by b to the seventh is just b in the numerator. That's all over 1, which is really convenient because now we can just write this as the square root of 7a squared b. And then a squared will come out as just an a, and so we have a root 7b. That wasn't too bad. Let's try another one. In the next one, we have the cube root of 64m to the 7th n to the 5th over the cube root of 2m n to the 3rd. Let's rewrite that as the cube root of 64 divided by 2 is 32. M to the 7th divided by m is just m to the 6th. And n to the 5th divided by n to the 3rd is n to the 2nd. So in the denominator, we just have a 1 again. Now 32, if you haven't memorized this already, this is 2 times 16. And 16 is 4 and 4, so hopefully you've figured it out already. We have 2 to the 5th is the same as 32. So let's rewrite this. The cube root of 2 to the 5th, m to the 6th, n to the 2nd, reduces to, now how many 2's could we take out? Well, if we take 3 and we divide 5 by 3, then we can say that 5 divided by 3 is 1 with 2 remainders. So 2 to the 1 comes out, and 2 remainders stay in the cube root. M to the 6th will come out twice, so m squared, and n squared will not come out at all. It has to stay inside with the 2 squared. Now let's look at part C. We have 81 w to the 11th, x to the 6th, over 16 y to the 12th, all under a 4th root. So let's see, will anything divide out? 81 is 9 and 9. That means that 3 to the 4th is 81. And then 16, well, we know that that's 4 and 4, so this is equal to 2 to the 4th. And I think we're just going to have to rewrite it. The 4th root of the numerator, which is going to be 3 to the 4th, w to the 11th, x to the 6th, all divided by the 4th root of 2 to the 4th, and y to the 12th. Now, why did I write it as separate pieces? Well, if you look at all the factors in the numerator, nothing in the numerator will divide with anything in the denominator. So then we can just rewrite this as 3 comes out, w to the second comes out, and we're left with a 4th root of w to the third inside. X to the 6th comes out once, with x to the second inside. In the denominator, 2 comes out, and y also comes out 3 times. No remainders in the denominator. Let's look at part D. We have the 5th root of 64a to the 11th, b to the 28th, all over the 5th root of 2ab to the negative 2. Let's rewrite this as the 1/5 root with a fraction inside. Now remember, when you have negative exponents, you need to bring them to the other side of the fraction. So we're going to rewrite this as 64 divided by 2 will give us 32. A to the 11th divided by a will give us a to the 10th. B to the 28th, and then if we shift the b to the negative 2 up, we change its sign, and so we'll have b to the 28th plus 2. So that is interesting. We have a 1 left in the denominator, so we don't even have to write it anymore. We can write it as just the 5th root of 32. Remember, 32 is 2 to the 5th, a to the 10th, and b to the 30th. All those exponents are divisible by 5, and so they're actually going to come out quite nicely. We're going to get a 2, an a squared, and a b to the 5 times 6 is 30, so b to the 6th. No radical left over, no denominator left over. Last one we have here is a cube root of x cubed minus y cubed over the cube root of x minus y. I have a feeling we need to rewrite this as one giant cube root. In the numerator, we can factor the difference of cubes. I'll have an x minus y. Same opposite, always positive. I'll have an x squared, an xy, and a y squared in the trinomial factor. In the denominator, I just have an x minus y. So if I look at the factors I can divide out, x minus y divides out. So now I just have a 1 in the denominator, so I can rewrite this as the cube root of x squared plus xy plus y squared.